Good morning, everyone. My name is Laurent Solga, and I will present our work entitled RFD Tracking System for Basketball Game. A few points about our motivation to take this work. We can observe that in a lot of sports, the contacts between the players became much heavier and the games are more dynamic. Because of this, a lot of effort were put to get new solutions to identify these contacts during the game. For example, in running, cycling, skiing, simple gauge system are used to identify this line crossing. In contact sports, collision prevention systems were developed, and in a lot of sports, image processing technologies are implemented, but these are not 100% accurate for the moment, and they require a lot of hardware, a lot of processing time to get the final result. And because of this, they are not very proper in a lot of sports. Case of the basketball game, the main issue is when we cross the line for the 3-point. This is the main issue that referees want to identify. And because of that, we came up with a solution that can work very good in this game. This is the hardware distribution, so we can see the basketball field and the two semicircles when we have the the 3-point line. Now, to identify the contact with the line, we have to implement a system to identify this. And for that one, we think to the um, infrared emission and receiving of the light, so an infrared emitter and receiver which can detect a traced line. So this can be done with this sensor. But now what we can do is to identify the player who walked down the line. For that one, we will use an RFD reader, and on the foot of the players will be attached an RFD tag. So on the left foot and on the right foot, we have two different RFD tags attached to the shoe, and like this we can identify not that we crossed the line, but we can identify as well the player who crossed the line. The length of such a semicircle is around 24.3 meters. For the distribution of the sensor, we analyzed the area of the receiving of the RFD reader, and we found out that it has around a 3 centimeter radius of detection of the RFD tags. So we distributed um, the RFD tags at the distance of 6 centimeters between each other. Like this, we need 405 RFD tags on a semicircle. For the infrared sensors, we took into account the tip of a shoe of a player, which is around 3.25 centimeters. So we are interested when this small length will get in contact with the external part of the 3-point line. Like this, we have to distribute this sensor from 3 and 3 centimeters. So it means that the number of the infrared sensor must be doubled than of the RFD tag readers. So we will use around 810 infrared emitters and receivers. Now let's see how we collect the data. So here we have the block diagram of one module which has the RFD tag reader. We need here we have the RFD reader, we have the ID82 infrared sensor, and we have power supply. So it's done by a 5-volt unit, and the board will have 3.3 volts for all the sensors. With all this data that we are collecting with the RFD tag, we will use an ESP8622 node MCU, which has already incorporated a Wi-Fi module, and we can connect to this development board the RFD tag reader and the infrared sensors. So we will have a compact modulus for each RFD tag, and around each RFD tag we will have two infrared sensors. So this one will be one of the modulus from 405 RFD tags. The logic of operation of the whole system, it's based on taking the data from the RFD tags. So first time we will create a MySQL database from where we have on the front page on where we have a registration form where we are taking all the RFD tags and read them in the database. After this data was read, we will distribute in this data into tables for team A and for team B. Here we will have the RFD tags for the players, the number of players, and of course for each leg of the player, left and right leg will have attached an RFD tag. From this data, these two tables can be edited anytime if we want to replace an RFD tag or we want to delete one of the players from the table. And we can delete, of course, the whole table if we want, and to add new teams. The main important data, so the player number, the RFD tag, and the node MCU number, everything will be extracted and sent over HTTP protocol, so over Wi-Fi protocol to the ESP unit, so to the 405 ESP unit. So each unit will get this data inside of it in the code for the initialization. When a player will cross the line, the node MCU is always reading in the loop the actions from the RFD tag. So it's reading if one of the players is crossing the 3-point line. It's identifying that leg of the player, and at the same time, if the line was crossed down, so we walked down, we had a contact with the line, at the same time it will show us if it was a direct contact with the line. All this data will be extracted, so sent back to the database, and after that in a new table, a game action table, all this data collected will be shown on a gameplay front page. So the monitor or the referee can see in real time all this data. Here we have a few pictures with the circuit and the PCB level of the implementation. Here we have two modulus, so the distribution of two modulus in a prototype floor. Here we have on the left side PCB attached with the ESP module. On top of it we have the RFD tag, and near we have the two proximity sensors, the infrared one. Everything is encapsulated in a custom 3D printed enclosure, and after these enclosures are encapsulated into the floor. This one is a system prototype floor with the two modulus. We can see them here, and the red spots are the red light from the RFD tags in action. And after we just put the black line to leave out only the infrared sensor, which are the main interest. So this is on the right side, we see the final image of the whole system. We have a picture with the tag readings. As we can see, we have for each player, here we have 5 players in team A, 5 players in team B, and for each player we have the left and right foot identified, and of course on the right side we have here the tags as well when we read them. For the tag identification, in the final table, in the action table, we have here the number of readings. We have the number of player, we have the team from the player it comes from, its foot number identified by the RFD tag, and we have here as well the number of the node MCU which identified this action. And in the end, we have in the last column, we have the time when this was identified. We can see that here we have two readings. So above the red line, we have another reading. So at the same time, we can take two readings, and the first one was taken with the first node MCU, and the second one with the second node MCU, and the data was sent instantaneously to the server, and the second node MCU identified with a yes that the line was crossed, that player number 5 from team B and with his left foot. In conclusion, we can say that our system it's working. So this prototype is working on a small scale. Now we are working to extend this one to the whole semicircle. We have to mention that Janko, it's a professional referee basketball in basketball referee here in Romania. So that's why we can have the possibility to work on this extension of our system. Thank you very much for your attention, and feel free to contact me if you have any questions regarding this work, and you would like to work on projects which implies optoelectronics or organic solar cells. Thank you.